So the most obvious thing to do would be starting with the network. Taking a look at our code. In our last video, you may remember that we talked about putting together an abstract class so everything that runs could be able to use the same signature in our Trek 1 or main game loop. So let's get started on the network, the moment I've all been waiting for. But since I've done so many of these before, I decided to let the AI get a crack at it first. And here's what the AI came up with when my requirements were simply to listen for a UDP connect from what the AI called UDP_client.py, so as to talk to this UDP server.py. So going through the code, of course, it's easy to understand because the protocol I came up with was simply to respond with the present date and time, which is fine, the client IP and the server IP, because I didn't really want to go and figure that all out again. You can see we got the IP import. Once we received our information from the socket protocol, again, the date and time was very simple. We just had import date time, and then format up the time, and the protocol was to simply return the client and the server IP, as well as let us know what's going on, something we'll probably want to log later on. Running our UDP server, the next thing, of course, would be to go and run our UDP client. And this is where you got to be a little bit careful if you're going to do your own AI gen, because you don't want to reuse this same prompt, of course. So the best thing to do, although you can run it through idle, to avoid a lot of problems, let's go ahead and instead open our file location and run our UDP client from another process altogether. So the odd thing here is that we got our response, but the server IP isn't going to work. It just doesn't work, and I've seen this before. And this reinforces what I've said all the time about artificial intelligence, is that it only goes so far. It did go very far, but not being an expert. And if we try to make it an expert, it probably won't get it because it has so much bad code out there that it assumes that the get sock name is going to work on all machines, and in my experience, it doesn't. To save us some time, however, here's a fantastic way to get things going. I don't like that port name either. It's very easy. But I do like the idea that they were able to listen on all network interfaces using hosts equals 0, certainly the one that I'm interested in. So let's go ahead and update our polymorphic client and server, if you will, using this wonderful AI-generated code. Revisiting our runserver.py file in our PyTrek home directory. Remember, it's pretty trivial. And the first thing we probably would want to do is simply grab everything we have under the AI-generated main, paste it directly underneath our run, put our tabby in there to create our listener for all hosts on port 1, 2, 3, 4, 5. The next thing, of course, to do would be to take a look at the client code, because the client code doesn't really do much. It's a dumb client, as we mentioned, and we simply connect to the internet using the datagram protocol and send them for UDP IP, as we haven't mentioned yet, and then have the server and the ports to be submitted by tuple into our encoded or byte encoded message, taking from Unicode to the standard wire octet encoded way of looking at business with a package size of 1024. And we print the decoded message, once again going in the opposite direction, from binary over to Unicode. Copying that code underneath our UDP init run method gives us a nice operational way of doing business, and also allows me to fix a few faux pas here from our last session, so as to make it so a little better. In other words, there's no need to import ABS runner twice, because it failed the first time. It obviously needs to be put in there, and if it didn't fail the first time, why put it in there again? Starting off with running our server then, in our test mode, we get the exact same display, and then changing directory to StarTrek. Once again, very important to be in a separate physical session now. Sometimes it works in idle, and sometimes it'll bite you. This way it never does. And then we'll see our result. Once again, that's not going to work. It's a pretty well-known bug that IT professionals know about, and I don't think AI is going to get there by looking at the code of, people who aren't IT professionals. So the question becomes, how can we do a little bit better with our game server testing so as to get our proper server IP address? Well, there's some other things we should probably look at here to fix up as well. So by way of a best practice, what I'd like to do is I'd like to get these manifest constants placed somewhere else so that we can share them between all of our programs. And lacking a better, let's simply create a file called ipinfo.py. First thing to do in ipinfo.py, of course, would be to, for example, take our hard-coded constants, in this case port, as well as the hosts, and change this to 9,000, simply because it's soft 9,000. I like that. And then we really need to do something here to get this information into our quargs, I think, would be appropriate rather than hard-coding things, so as to accept our defaults. You'll also notice that we have a buffer size here of 1K or 1024, which I also like to change about a bit, and I'll call that the IP message size simply to allow us to use the IP message size rather than have another hard code in our code. Keeping consistent, let's go ahead and import each one of these things specifically because it's going to grow. Port the host, the port, and the IP message size. And we'll change that to UDP port later on, but keep the ripple effect from going too far. We can still bind to our host and our port. Of course, the next thing to do would be to pull any manifest constants out of our UDP initializer. For example, you may remember the IP loopback port, the classic 127.0.0.1, as well as our ports and message size redefinitions. Once again, to simply import some very plug-and-play hard codes into our plug-and-play code for our polymorphic UDP initializer. So let's give it a try. Everything's fine because we're now connected to port 9000 using our manifest constants. All is well. So to make things better, we probably want to put in our quargs convention. And here again, starting with our server, and this is another caveat to be aware of, I'm going to be able to stop it rudely, just like we do right now, and get away with it. In the past, I've had troubles doing that, but since I came out with my video, it seems that more people are doing sockets beforehand, so we do have a terminating socket routine that I won't go into that actually deregisters things with the operating system rather than leaving the port reserved with a bummer handle. All I'm trying to say here is beware. You might have to restart your machine. If you're running from idle, it might just be better to run the server as well as the client from the operating system shell in two separate command lines if you have a problem researching and developing your IP socket code. So the first thing we want to do, of course, at least on the server, would be to update our quargs to manage our information. So as I'm fond of saying, software development is a lousy, actually I'd say pretty poor spectator sport. So our Make It So mission, which we'll be demonstrating in our next video, is to simply make it so by hacking an AI. And make sure while you're hacking, if you choose to do so, to create an ipinfo.py, that's our official name, as well as to update the keyword arguments to the quargs And if you'd like to try AI or simply freeze frame my previous code and type in what you see, and take a moment and do that now to improve your muscle memory. See you next time.